Hello there, this is KP the MFG, ready to do another video. I tell you, been working on our greenhouse for the last few days and I've got some stuff planted. Well, I say, I've got some starter plants. I've got some tomatoes, and there's a lady who wants an eggplant, so I'm going to get her an eggplant, and my wife wants some spinach, so we're going to have some spinach. So I've got those three, and then coming up on the 6th of this month, which is in just a couple of days, I want to say it is, we're going to do some watermelon and cantaloupe, so we're going to work on that. But I wanted to come back. I've been working on this problem for a little bit now, and I have got it on. Actually, I've got this on my phone. I downloaded the TI-84 Plus, and I've got this screen. I don't know if you can see that or not. This screen is on my phone, and so it may be for a limited use only. I don't know that for sure, because these things, are at least $100 or more. So I did manage to work the problem with my phone calculator. I got one calculator that will not do the definite integral, and one will, but one will graph and the other one will do that definite integral, but you can't have two calculators on your test, so be that as it may. Alright, let's go ahead and get started. This is the last part of the 2005 free response question 2. This is actually part D. We answered actually parts 1, 2, and 3, and now we're looking at, well, A, B, and C, and now we're looking at part D. It says in black here, of course, let's look at everything before we get into this. A tide removes sand at a rate of 2 plus 5 sine of 4 pi t over 25. A pumping station adds sand at a rate of 15 t over 1 plus 3 t. At t equals 0, we have 2,500 cubic yards. Our units in, let's see, our units in, as far as rate goes, is cubic yards per hour. So if you're just talking about amount of sand, it's just going to be cubic yards. For the question we have here, for t being between 0 and 6, including 0 and 6, and there's a reason why we have to include 0 and 6, at what time is the amount of sand a minimum? Now remember, when you have a function, in this case from the last problem, we found that we had to come up with a function of y. Y at t was equal to 2,500 and plus, alright, we're going to add, okay, we integrated from 0 to any time t, 15t, alright, over 1 plus 3t, alright, and then that minus the amount that is removed, which is 2 plus 5 sine of 4 pi t over 25, and close, and then close again. Alright, dt, yeah. Alright, now when you talk about a minimum, you take the derivative of that, don't you? Okay, so what we're saying is when we do that, alright, then we come up with, when we take y prime at t, then we know that the derivative of this is 0, and all that's left is this with the t included. I think this might have been an x at first, but anyway, minus this here. So in other words, what we're saying is no dt on the end, of course. All right. It is going to be s at t minus r at t. If it's going to be a minimum, we know that there's going to be a horizontal tangent. So in other words, the slope of the tangent line to the curve has got to be equal to 0. So it's when s at t minus r at t is equal to 0. And obviously, if you solve this, you have, if you add this to both sides, okay, like this, you have s at t is equal to r at t. And we want to know when they are equal, okay? So that's the point we're at right now. We want to set this equal to this. And on the computer, on my calculator, on my phone, I'm going to flip this over and show you. Alright, so what I did here was, simply put, I did this, okay? I'm just going to show you, I can show you on my calculator. So I have y, so, well, in this case they're doing y at 0, so anyway, it does not matter, okay? X is equal to, and it doesn't matter which one you put in here, so if you're going to see that they're equal, you got to see that there is a point of intersection there. Okay, you got to see where, okay, so let me go back to what I'm talking about. When we talk about a minimum, we got to look at the endpoints, okay? Now this is when the amount, alright, I'm going to have to integrate again. So amount, alright, we're not looking at rate, we're looking at amount. But at first we got to find out, we got to set this equal to each other because we are taking the derivative, and we have to set s at t equal to r at t. Alright, so that's what we're saying. This minus this, in this case, equals 0, because we want that to equal 0 because the slope of the tangent line is 0 when it's a minimum, or it's 0 when it's a maximum. So whether you're doing a max or a min, you have to set this equal to 0. Okay? Alright, this rate minus this rate is equal to 0. So in other words, s at t is equal to r at t, and that's what we have here so far. Alright, so that's what we had to do. We got to find that number. We're going to set them equal to 0. So in other words, I put in my calculator, it does not matter the order that you put this in. So 2 plus 5 sine 4 pi x, and I could do mine with like this. I could do this. I do have a n over d, but I have to hit second and then n over d. Okay, and then this is going to be over 25. All right, and then y 1 at x. All right, yours may have y1 and y2. Okay, I don't know, but anyway, this is what mine has. All right, mine is the 15x over 1 plus 3x. Okay, this is the rate that we said that this is actually s at t, and this is r at t. Okay, so we just want to set them equal to each other. We want to find, when we say they're equal to each other, we're looking for a point of intersection. That's when we say, at what point at what point do, say, two lines that intersect here, at what point R is, say, let's say this is F, and when is F and G equal to each other? So if F is equal to G, then we want to find where do they intersect. That's what you're really looking for. Okay? Alright. And so that's exactly what that means. You're looking for a point of intersection. Alright? And what that means is, in this particular case, we are already looking at let's see, what is that function? Y at 0, which is already given to be, we've seen it from the other videos, that at t is equal to 0, we have 2,500 cubic units. Okay, so we're already at that one. That one was easy. Okay. Alright. So that's one of them. And then y at 6, we need to figure that out. And then y, if there is a critical number, that's going to be when these two intersect right somewhere here. We're going to look at the x value, whatever that is. So if x is, say, 4, that's what we're going to use. Okay? So that's what we're saying. We're not worried about the y value. We're only worried about the x value here. Okay? Because this is equal to time. So we're looking at time, so we don't care about the y value here. Okay? Alright, we're looking only at the time. Alright, so you might have something that looks similar to this. Okay, so you might have something that says t and then something at y at t. Alright, in this case, if t is 0, we have 2,500. And we got to look at 6, and we got to see if there is a, what we call it, a critical number between 0 and 6. Then we gotta look at all of those as well. I did graph those. Okay, so when I hit graph, okay, this is what I came up with here. So if you look real carefully, right somewhere after 5, okay, if you can see that, I don't know if you can see that, but right here after 5 is the place where they intersect, where the red line and the blue line intersect each other. That's where they are. Okay. Alright, so let's see where they intersect. I have a little symbol down here. I love it. It just says intersect right here, and it automatically tells me what my x value is. 5.11787, something like that. Okay. Do you see that? I don't know if you can see that all right. Let me see if I can get a little closer. I don't know if I'm doing you any good or not, but because I can't tell what's on the screen. Maybe I can. Let's see. I'm looking at the screen too. Oh, I don't know if you can see that. I'm trying to look at the screen myself from behind the camera, and there it is. Anyway, that's it right in there. Oh, that's it right there. Okay, I don't know if you can read that or not. Okay, there it is though. It is this number is 5.11787 is what I've got here. Okay, now if you want to round off to 8 right there, 118, that will be okay. You can go 3 decimal places there. Alright, so I think they put 6, good gracious, 787, I got 786, okay, I got 7865. They rounded this 65 to 7 here, okay. Okay, alright, that's what I have here, right there. So I'm looking at 0, which we already have. Now, what I want to do is I want to integrate, and I want to say I'm going to add 2,500 to this plus. And if you want to do it that way, I just integrated first, and at the end I got plus 2,500. So what I did, well, I actually forgot to put the plus 2,500 plus on that. But you're going back to, because you're integrating, alright, so you're integrating here. So if you want to, you can do, I just went ahead and did this. I went ahead and did the integral first of all. I did it from 0 to 6, alright, and actually if you want to, you already know what S at t, if you want to do it that way, you can show it that way, minus r at t. Alright, dt here. Okay, if you want to show that and save yourself a little bit of time, you can. If you want to write out what S at t is and what r at t is, you can do that, but you eventually got to put it in your calculator like so, and when you do, you get an answer on the first one. When I plug in the 6, let me scroll down if I can. Yes, I can. Alright, I got a negative 6.7233329 and so on. You don't have to go that many, but when you add 2,500 to that, you get an answer of approximately equal to 24. I'm making sure 2493.276 or 277. So right here was at 6. I got 2493.277. That's what I got on that one. Okay, 2766 is what some people got. Yeah, it is 2766 if you want to go that far out, but you can round that to 7 there. If you want to put 66, that's perfectly fine. I don't know, either way is fine, because you went out, if you've gone out 3 digits, you have done your job. This is smaller than this, so we know at least this one is minimum to this one, but is this one minimum? So what I did was, I just went back to the original problem here, and I changed up my integration here. So all I did is I scrolled back and I changed this right here. This is the only thing that I changed. Okay, and also let's see, this one was 5.111787 is what I think. 7, 8, well, that had 6.5, I don't know, I just went ahead. You can put 6.5 if you want to. It doesn't matter to me. Okay. If you integrate that, you're going to get something in the neighborhood, okay, of, okay, it's going to be a smaller negative number. So I've got, actually a larger negative number. I've got a negative 7, oh my, that 7 looks terrible, doesn't it? Negative 7.630517 plus 2,500 plus 2,500, and then I got, that's equal to 2492.369. And again, you can only go, you don't have to go out but three spaces anyway. So 2, 4, same digits so far. 9, same digits so far. Not that much difference here. Okay, but now, well, we're already low enough now. But anyway, 3, 6, 9 here. Doesn't matter what these are. This one's smaller than this one, and so this means that we have a min. All right. So the question is the minimum value is, okay, the amount of sand, I'm just going to abbreviate this, of sand, alright, is a minimum alright when t equals 5.117865. I think they went on out to 118, which is okay. I mean, you can round that up to, that's what they went out to. Alright. The min value is, and this is probably going to be amount of sand in, oh, what are the units? Cubic yards, okay, is 2,492.369. I want to say that's going to be in cubic yards, yeah. And cubic yards, there it is. Or you can just simply write CU, either way, cubic yards. And that's what you're talking about. This is the time. This is in it in hours? Yeah, 5.118 hours. The amount of sand is going to reach a minimum, and it's, see, the maximum amount was 25. Well, so far the maximum, if you had to have a max, it would be 25. That's what you started off with. At t equals 0, you would have the most amount at t equals 0. And then, of course, you're going to have a minimum amount at t equals 5.117. You would have a little more sand a little bit, almost an hour later, okay, but again, we're only going from 0. And also remember, this is the extreme value theorem that you must keep in mind. That's why the endpoints on the other side were included from 0 to 6. That included the 2 endpoints. You must always check your endpoints, not just a critical number. You can't just do the critical number. You already had 0, you had to find 6, you had to find 5.118, which is somewhere around that amount of cubic yards of sand. Okay, that's reached the minimum at t equals 5.118. Okay, so a lot of things you had to do is, when you have a minimum, you have a y at t. Again, I'm sorry for, you got to take this y prime at t when you see the word minimum. Alright, because you got to take that derivative of this, and that's when s at t minus r at t is equal to 0. 0 because the slope of the tangent line is equal to 0 there. And then once you find that number, you're in business. You had to find that number because to graph, you had to graph those two functions, see where they intersect, hit intersect, and then you should see where they do intersect, okay? Alright, and then once you get that, then you got to come back because it says amount of sand, so you got to integrate this here, okay? Amount of sand you have minus the amount of sand that's leaving, okay, due to a tide. Okay, and so you had to do that, and then add 2,500 to that, because that is, you can't just go with these numbers here. You got to add 2,500, and you could probably do that from the beginning if you've done that. So either way will work for you. It should do that. This is not one of the easier problems to think about. It can be a little difficult, but you remember, minimum or max, you got to take a derivative. You got to find the critical number. That's when you find where they intersect. After that, then you use that number along with the endpoints of the, this theorem here, okay? Because of EBT, you got to check this right here, okay? All right, extreme value theorem. And then once you find all of these, you find which one's the lowest. And if it's a max, you're going to go with V it or Y at 0 in this case, okay? Like you were looking for a min. Okay, that's it for me. Please, if you want to, you can please subscribe if you haven't done so already. I do appreciate those subscribers. Appreciate every one of you. Every one of you. Really, that is a big encouragement to me. And if you make a comment, that's good. I appreciate the comments. If you want to hit that like button, please do so there. I hope this helps you understand this somewhat better anyway. Okay? And it took me a little while to figure this out for a while. I mean, when I first started doing this and first started teaching it. But after you see it for quite a few times, it starts to come together. Alright, well, I hope this will come together for you as well. KP the Math G signing off. Ladies and gentlemen, have a great, great day.